Hi, welcome to my video on proving trig identities number 5. So we're going to prove this trig identity, which has a left side and a right side. And it looks like the left side is more complicated, so I'll write down the left side. And I'll write down the right side. So the left side is 1 over 1 plus cos of 90 degrees minus theta, subtract 1 over cos squared sine squared plus sine of a negative theta. And that's the left side, and the right side is negative 2 tan theta secant theta. And as I said before, I'm going to prove that I'm going to work the left side down. Notice you might say that I'm working the left side down. Most times that's not necessarily true. You could also work the right side down to become the left. So let's work this side. So we have two fractions, so I'm going to see if I can simplify inside of this fraction here. So the cos of 90 minus theta is a cofunction, so cos changes to sine and sine theta. So theta is in the first quadrant, so cos is positive, sine is in the first quadrant, positive. Again, when you do a cofunction in terms of 90, the trig function always changes. And we have a 1. And we have cos squared plus sine squared. Cos squared plus sine squared is the fundamental identity, so that's 1. And sine of negative theta in relation to sine, it's sine of negative theta is sine theta. Theta is in the first quadrant, sine is positive in the first quadrant. Negative theta goes to the fourth quadrant, so that's a negative. Now we have that side simplified, so let's look at the two fractions. So right here, this is 1 subtract sine theta, so let's just rewrite that to keep it straight, so with no confusion. So we have two fractions, and the common denominator is the product of these two because they're different. So I'm going to take the first one and multiply by 1 minus sine over 1 minus sine, 1 plus sine, subtract, and I'm going to take this fraction right here and multiply it by 1 plus sine, sine theta. So multiplying it by 1 minus sine theta over itself is the same as 1, and there's a 1. So we're making equivalent fractions, so multiply, we get 1 minus sine theta all over 1 minus sine, 1 plus sine. Subtract, multiply, I get 1 plus sine theta, and the product of the denominator is, I'm just rewriting down, so 1 times 1 minus sine, there it is, and 1 times 1 plus sine, there it is. I have the same denominators, so we will write the denominator down. I got the same denominator, so I'm going to write it down. Common denominator. Now I'm going to take 1 minus sine theta, and I'm going to subtract 1 plus sine theta. When I subtract this, that makes it negative 1 minus sine theta. When you subtract, you add on the opposite, and it's the opposite of the numerator. So that's a plus becomes a minus, that's a plus becomes a minus. And the common denominator There's only one denominator now. 1 minus sine theta, 1 plus sine theta. And 1 minus 1 cancels out, so that gives us a negative 2 sine theta. And how's that looking like up here? Well, again, you go to a sheet of scrap paper and write this down. So I have a negative 2 sine, negative 2, tan is sine over cos, and secant is 1 over cos. So when I multiply that, I get 2 sine theta over cos squared. Remember, these two are done on a sheet of scrap paper. The teacher doesn't see it. You don't have to show it. But that leads us into here. So this is negative 2. So I got the negative 2 sine theta. There it is. So that means that 1 minus sine squared and 1 as a plus, 1 plus sine squared must become cos squared. So how do we do that? Well, we just multiply it. So this is the factors of difference of two squares. So if you multiply this out, you get a 1 plus sine theta minus sine theta minus sine squared. So I multiplied that by file. First, outside, inside last. So that gives us a negative 2 sine theta. They cancel. That's 1 minus sine squared theta. And we keep going. So that's 1 minus sine squared becomes a cos squared. And it looks like that. So I can't keep going down, so let's go up here and reverse it. So this step is right here, so let's take this step and put it right here. Again, it should be going on down, but I don't have the space, so it's negative 2 sine theta over cos times 1 over cos. So that step, I put it here. Now this step, negative 2, that's tan, and that's secant. And so we have it done. Since left side equals the right side, it is an identity. So this is the official way to prove it. You work one side to become the other. Now, if you wanted to, if your teacher allows, if you're writing an exam or doing homework or doing exercises, if your teacher says you can stop here, if you can work this side down to here, and if you can work this side down to here, then the left side equals the right side. You wouldn't have to do it this way. Again, the official way is to work the left side to come up with the right side. And again, this is done on a sheet of scrap paper to show you how to connect it. So that's the end of this video. And again, a different example. And again, if you like my video, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.